Is everyone doing? All right. Oh gosh. I don't think my monitor was muted. My bad. Probably got a little bit of echo there. Just a little bit of echo. That's my bad. All right. So we're going to have just a little bit of time for people to filter in. Big news. I guess not really big news. Taking next weekend off. So it's family weekend. So I won't be streaming at all Saturday or Sunday. Now I'll stream Thursday and I'll stream Tuesday like I normally do. So yeah. So there was a lot of stuff that happened this week that we gotta... Everything from major releases in WSL to like, which is maybe like the least important thing. The least important thing that we have going on. We have major release for WSL with some huge things that I have been personally asking for. I don't even use WSL that much. We got a bunch of stuff from GitHub, but maybe the biggest thing is there's a new competitor in town for GitHub, which is pretty interesting. We're going to talk about it in our open source section. Our open source section is jammed packed this week. Absolutely jam packed. We have everything from Gitness, a new GitHub, effectively. It's the whole package, to a bunch of stuff from like people stepping down from open source driver support for GPUs. We have a new thing called K2d, which I'm kind of actually excited about. We're gonna have to play around with it in a live stream at some point, because honestly, every Kubernetes edge deployment to me has had the same problem. You build a lightweight Kubernetes, and that's fine. You know, your K3ds, your K0s, whatever it is, it's fine. But the problem is Kubernetes itself seems to be too heavy sometimes. That's the problem. You didn't simplify Kubernetes itself. You just kind of simplified aspects of it. So K2d is very interesting. I believe that was brought to us by the community, so good job to you guys. I had not seen it. We have the Linux Foundation taking on Terraform. It did it in an interesting way. Long-term support. A new project called Camel, which might be interesting to you. An RFC to update the policies for crates.io. We have a bunch of stuff to cover in this episode. We're going to try to cover it as simply as possible. Like I said, I'm trying to go a little more in depth than broad, but there was so many interesting things. Now, luckily, there wasn't a whole lot to talk about in the clouds. Basically, effectively, nothing. So we got a little bit of a break there, and our security and whatnot was a little bit less. So yeah. To round off all of this, at the end, we have 2 articles to cover. We'll cover one this week, and we'll shelve the other one for another time when you guys would like to. I could do it during the week if you guys would like, on a Tuesday or whatnot. Just do a little bit of a review of the article. The one is on zero configuration service mesh with on-demand cluster discovery, and async Rust is a bad language. Both are an interesting thing. All right. Should we get into it? Maybe I'll give just another minute. One more minute. I usually start late, and now I'm late, but less late. And less late could take people by surprise. All right. All right. Let's jump into it. Our first one. It's in security. We're going to talk about security, but this is going to probably teach you, hopefully, to make sure your API keys and secrets are not in GitHub easily discoverable, because it turns out that GitHub Copilot, Amazon Code Whisper sometimes emit other people's API keys. This is a new attack vector from these large learning models, where they'll actually happily scrape these things for you and insert them into your own project. So this is a little terrifying. Just another way machine learning is coming for your job by stealing your API keys. All right. LastPass has yet to fully recover. They have finally started requiring people to change their passwords. If you haven't been on the entire train of the LastPass, it's been going on for 6 months or so. I'll give you a little bit of a brief history. They were breached, as it happens, and they managed it very, very, very poorly. They first semi-hid that they were breached. Then they basically said, oh, we were breached, but no customer data was stolen. And later do we find everything was stolen, including their vaults. And then they were like, oh, well, it's fine because everything's encrypted. Well, as we know, encryption only lasts so long, and it turns out they didn't use very good encryption. Now, from the very beginning of this, I have personally championed for people to reset their passwords, to change their passwords ASAP. Their LastPass password. And it turns out that over the last couple of weeks, people have been losing millions of dollars of crypto as people siphon it off of these accounts as they crack those LastPass passwords. Now, finally, they are forcing people to reset their password on login. It has taken an entire year for that to happen. And, I don't honestly know if the company is going to survive this. I know myself, I would not use them, but I want to know what a lot of you guys think. Would you guys use LastPass at this point? Would you guys actually take that risk, trusting them with all of your passwords? Let me know. I personally think that trust in a company like this is paramount, more so than even a company like Unity. So, I'm definitely interested to see where that's going. All right. That was it for security. Did you guys see anything in security that I missed? All right, well, we're going to jump into some general news. There, like I said, we have a cloud news section. Not going to jump, but you know what? Let's jump right into the cloud news. We'll circle back for the other news. There was very little cloud news to speak of. We have one interesting thing out of AWS, which is Amazon EC2 M2 Pro Mac instances built on top of Apple Silicon M2 Pro Mac Mini computers are now coming out. So you have the general availability of these. So if you're looking for that M2 in a data center for some reason, you have it. I know that a lot of people use these for like testing things that are required to be tested on an Apple. So if that's you and what you're finding, there you go. Russell, I didn't start early. I started on time, which is my bad, because now I feel bad because people probably thought it's early. I always mean to start at 4:30, and it always is like 4 or at 4. And, I actually started at like 4:05. So that's my apologies, which is early. I understand. Next is Null Dev. Hey, it's good to see you. It's good to see you. So you guys didn't miss a whole lot. You know what? Because you guys are fantastic, I'm going to recap really quickly. We just did the security, and there was just kind of the final nail in the coffin of the LastPass drama that has happened. The LastPass drama is out there, and basically they didn't require people to for the whole year, haven't required people to reset their password till now, and people have lost millions of dollars in crypto. I was wondering from you guys if you guys would trust LastPass at this point. I think when you're talking about something that's going to store all your passwords, that would take a lot of trust from me. I would want to know a lot about that company. And honestly, it's been a saga. It's been a saga. But they are now finally requiring people to reset their passwords, which is fantastic. Next is Null Dev. Congratulations. Good job. Trust me, if I gave you anything on starting to learn Rust, it's going to be painful at first. It's going to be painful at second, and it's going to be painful at third. But at fourth, it's going to start feeling amazing. It's going to start feeling amazing. That's my... Okay, now I hate you, Nexus Null Dev. Now I hate you. It was not easy for me. The other thing in security that we covered was GitHub Copilot, Amazon Code Whisperer sometimes emits other people's API keys. So this is another thing you have to be thinking about is we have these LLMs that are going out there and scraping your API keys. So if you accidentally committed it to code at some point, you never know if an LLM scraped it and is going to start inserting it. This is a way that people could actually try to start getting free resources is by just leveraging GitHub Copilot and Amazon Code Whisperer to provide them a valid API key. I think it's very important, maybe even more so than it used to be, that you do not ever put your API key in the public. It's always been super important. Let me be clear. But it turns out that these things are very good at finding them. So at fourth, the Stockholm Syndrome kicks in. So you think you like it? I mean, the Rustling book is a fantastic book. Absolutely awesome. It's a good book. I think there is some, when you get into actually using it, there are some things that make sense, but don't make sense. You got to kind of get your hands dirty. At least for me, I always find that I have to get my hands dirty. All right, so what was it? Okay, so one, you're gonna have lifetimes. You're gonna have to deal with lifetimes, and you can read them and understand what a lifetime is. That doesn't mean that you know how to use them with threads. It doesn't mean that you know how to use them in complicated areas. It doesn't mean that you understand why you would have to pin memory. Those are types of things, like, it's really good to have read the Rustling book because it's going to help you search and find the right thing quickly. But I still struggle with several of those those topics. Crossing thread boundaries is fun. That's right. It's fun. That's the word for pain. Is fun. I mean, it's all good. It's all good because it's protecting you, but yes. Channels are so good for a few things. Channels aren't the solution for everything, though. Stockholm fun. That's right. If you can purely use channels, that's great. That's great. But then are you using async and await? Because a lot of things like a Tokyo-driven web application, we can get into it. This is the news. We can talk after the news. We're going to jump back into the news. You got me sidetracked on Rust. That's always easy to get me sidetracked on. There are times when channels aren't the easiest solution. Will be what I say. But we'll get, and you'll want something like futures. Although, if you guys were here for the introduction, I gave an introduction, and one of the things that we have to do a reaction to is async Rust is a bad language. So, if you guys stick around to the end and want to go over this and we can talk about it, this would actually be a perfect time to talk about it, Nexus Null Dev. You have about 25 minutes. Perfect. We have about 25 minutes. I'm sure. I'm sure we'll get done. Okay, let's get going. All right, Google had absolutely nothing. They didn't release anything. At least that's what their documentation said. Azure did release one thing that I thought you guys should know about. Azure Monitor for AKS engine will not be supported on the 14th of September, 2026. You have some time to still use this, but yeah. So there is now a Azure Monitor when you migrate to AKS. So you just need to enable this. It seems pretty easy, but you need to be aware of it. Did Google close anything down this week? I don't know that Google closed anything down this week. I don't know that happened. Though I'm not going to say that they didn't because it happens quite often. All right. Now, there's actually a pretty big release for WSL. I don't use WSL very much. I play around with it every once in a while, but I don't use it a ton. I do know some people have really liked WSL, and I noticed that there was a large release coming up. Something that I have actually asked for is in this. I'm going to assume that it was because I complained about it, but yeah, so that's for sure. Now, if you guys would like to see a good explanation about it, this is a person that made a video about it that you can go read and watch. But WSL released their 2.0.0 pre-release, released it this week, and it has some pretty cool stuff, including networking mode, a new networking mode for WSL that adds new features, improved network compatibility. Now, that doesn't sound like a whole lot. The auto memory reclaim is actually a pretty big deal. But this is actually probably this and the auto proxy are probably a pretty big deal from a usability standpoint. So let me pull up. Okay, so the mirrored networking is basically what this allows, is a thing with mirrored networking, basically so that your networking is the same, so it's easy to actually access different things on them. One of the big improvements that comes is fixing the micro K8s and improving that with the mirrored networking to allow you to use micro K8s more natively. So I know that some people use that in their Windows, and that could be some issues there. We won't talk about IPv6 because that's pretty much the worst. But yeah, so this is pretty big. You should go and read this guy's explanation for it. You know, he goes into a lot more in it. I've heard that it's a really big deal. I haven't actually gone into it yet, but you know, I might enable it. So I don't know. Do you guys use WSL? IPv6 is awesome. IPv6 is awesome. Let me state that. IPv6 is awesome. WSL is the answer to I want to use Linux, but IT will only support Windows laptops. 100%. I agree with that statement. It's also I have some tool that has to run on Windows. I don't know what that is. Actually, I do know what that is. I had to run a tool like that because I made a machine image for Azure. It was a Linux machine image for Azure, but their verification thing to get it on the marketplace, their Azure marketplace, only ran on Windows. So I had to run in Windows. It was horrible. Horrible. So yeah. It was the worst. All right. So GitHub had a couple things come out. So let's talk about those. GitHub, now GitHub is interesting because there's actually a new player in town called Gitness, and we're going to cover Gitness right after we cover this. Maybe we'll have to host Gitness ourselves. It looks too good to be true, honestly. It honestly looks too good to be true, but GitHub is going to have to step up their game a little bit. in GitHub, passkeys are now generally available. So if you've been wanting to use passkeys, you now can. It's generally available. Now, not a whole lot of services are using this. I think Google is about the only other big player that's using this. I think Microsoft might have this in beta, but again, you're going to need a lot more adoption before you can get rid of your password manager. You're going to need a lot more adoption, but this is good to see. I am excited about it. They didn't stop just here with passkeys being generally available, but they also made a new migration service that's going to allow you to switch from Bitbucket servers and Bamboo to GitHub. So they did a lot of work to do that. Now, the problem they didn't do is they didn't make a service to switch from Gitness to Gitness, because that's what everybody's going to be doing in the near future. They are announcing the GitHub Innovation Graph. This is interesting. I'm going to actually link this to you all. This is interesting. So what is Gitness? Nexus Null Dev, that's why you're on the news section, because you want to know what Gitness is, and I'm going to show you what Gitness is. It's a new way to Git, and we need a song about a new way to Git that was just released. All right. So the GitHub Innovation Graph is their open data and insight platform on global and local impact of developers. So you can read what they're saying here. For too long, measures of innovation have focused solely on things like patents and research papers, while policymakers and researchers have had trouble finding reliable data on global trends in software development. GitHub's solution is the Innovation Graph. So this is basically trying to bring all those things together. Now, when I tried to go here, we'll try it again right now, I couldn't actually access it. I kept getting errors. Yeah, application error, client side. I can't access it right now. So the Innovation Graph has innovated well beyond its means. It's too innovative. It's too innovative. That's all I can say. So we can't actually see it yet. We can see who it's for and whatnot, but yeah, we can't look at it. I tried. And the last thing, and I think this is really cool, if you're trying to learn, I always try to bring up when I see new educational content, even though you all know that my educational content is the best educational content. They're bringing more educational content out there. So go here and learn if you're trying to learn. GitHub has a couple different paths for learning. And yeah, now this one is focused around Git and GitHub itself. So it's only really specific if you're wanting to learn more about those two things. But yeah, it's pretty good. Now, I have to say, I'm kind of excited about this next bit. We're going to jump into open source itself. And you know what? There's actually been a lot happening in open source this week. For all of you that haven't been up to date, we have Gitness, but we also have stuff like the long-term support and something called K2d that I'm pretty excited about. I believe Russell brought K2d. One of the community members did. I'm pretty sure it was Russell, so thank you for doing that. Please feel free to bring those types of things. I don't see everything. We also have something called Camel, but not OCaml, just Camel. That has come out from the good old makers of David Harrison. They're probably going to take type definitions away from Camel, but we'll see what it is. And it looks interesting. I'm interested in Camel because I'm interested in things like that. We also have a policy update for crates.io, but we're getting into that. Let's jump into it right now. The first thing is Gitness. Now, first, I have to say they did a fantastic job on their website. But Gitness is a new Git platform. Your lightweight, super fast code hosting. My goodness, my English today. Code hosting and continuous integration service. So the CI/CD part is powered by Drone. If you guys have ever used Drone, it's another project that Harkness provides, another app. So you can check out Drone. Basically, it's powered by this. Last I knew, Drone used to be open source, but I don't think it is anymore. One second. Yeah, it's not. So I'm pretty sure when they're now Gitness is open source, but I think the CI/CD that it's powered by is Drone, which means it's actually running on Harkness infrastructure. You got to pay for it. So, anyways. The idea of Gitness is that it's an open source developer platform with source control management, continuous integration, and continuous delivery. So it's kind of like GitHub. You think of GitHub, you have GitHub Actions, you have the code itself, you have pull requests, and things like that. So as far as I can see from Gitness, I have not run Gitness, but I kind of want to because they have a really easy using Docker. So you can just do Docker run. So we're probably going to have to do this on a stream and just test it out, play around with it, see how we like it. But yeah, we're going to have to try it because something I thought would be really cool with this was, we've thrown around an idea of a project called Assembly Line, and I feel like it would fit perfectly in something like Gitness, where you marry two open source projects together to make something better. Or they should open source, Drone CI, but I don't think they will because it was. So all right, Gitness is built on top of Drone to create a new... I guess maybe they're releasing Drone with this. Oh, that would be cool. That would be... maybe they're re-releasing Drone. Drone used to be open source. I guess I should have read more into this if I was going to announce it on the news, but Drone used to be open source. But it's built on top of Drone to create a new open source developer platform with code hosting and pipeline capabilities. Gitness development branch is taking place in the master branch, and Drone development will continue in the Drone branch. And okay, so wait, there's a Drone branch? There's a Drone 2, and a Drone 143. Which Drone branch? I'm assuming it's this one. Okay, so that's actually pretty cool. I'm even more excited about this now. So this is something we're definitely going to have to be watching and playing around with. I think it would be super fun since we do everything the hardest way to start. The one problem with, you have to have a good backup solution if you're going to host your own code, because if it goes down, it goes down. So you have to have a good, so we'll see if we actually host this ourselves, but I'm pretty excited about a good open source solution, because so far there hasn't really been a good open source solution that provides something like GitHub. Because to be honest, GitHub provides so much more than just Git. You can do a lot of stuff with just Git, but the ability to see pull requests and to have issues and your CI/CD built directly in is actually really powerful. And it's just not part of Git directly. And I haven't actually seen a really good all-in-one solution like GitHub. Now, some of you will say something like GitLab, and obviously GitLab is its own platform as well. So there are some other platforms out there, but an open source solution, I haven't seen so many. So Git-T, I haven't used, or is it GT or Git-E? I don't know. Git-E? Git-E. I'm going to call it Git-E. I haven't used Git-E a whole lot. Do you like it? The last time I looked at Git-E, it didn't have like actions and like a CI/CD built into it. It was more of issues and pull requests, which is great. You don't have to have the CI/CD built into it. Maybe we'll do a comparison video of Giddy and Gitness. Would that be fun? We can do a comparison stream and then a comparison video based off of that. It's a basic GitHub? Okay. Maybe we'll do a comparison stream. We'll give them a try. All right. The next thing is the maintainer of an NVIDIA open source Nuvo Linux driver. I never know how to say this. I'm destroying it. I know. So the maintainer is stepping down. I want to congratulate. I want to congratulate them because Ben has dragged this going forward since 2008. And that's amazing. So congratulations, Ben. It's awesome to see you moving on. I'm sure that people are sad that you're moving on, but maintaining something since 2008 can be a drag. I mean, that means they have been at it for 11 years now. And you know what? I think that they were stepping away when it was in a good spot. So there's a lot of stuff happening with it. There's a lot of things that are going to be making it easier in the future. And so I think this was probably just him being a little burned out. And that's good. It's good to know when to take a step back. But I know he'll be sorely missed. I know that Ben has been the backbone for this. Yeah. I just wanted to point this out and say thank you for your service. That's exactly right. I know a lot of people are in a better spot because of your work, myself included. So hopefully NVIDIA steps up. So, yep. Now, on top of that, long-term support for Linux kernel to be cut as maintenance remains under strain. So there was work to have long-term support for the Linux kernels. There's currently 6 long-term supported Linux kernels. Basically, they're looking to cut that down. They're looking to make long-term support less because it's too much of a strain on the open source community. This is much more sad than this. I get it. It's hard to be a maintainer of a Linux kernel. The Linux kernel is hard. It's gnarly. You know, I would offer to help, but I wouldn't even be any good at it. And so, like, it's a little sad to see these people under this much strain. Hopefully, there's people and there's companies that can contribute time, because I think the long-term support of Linux kernel is important. It's important for companies that rely on it as well as distribution. So I'm looking for Red Hat, Ubuntu, SUSE. These people need to step up and give more developers time to maintain the Linux kernel. Even Microsoft and AWS. These companies should be doing it because it's going to actually benefit them as well. So, all right, K2d. Is this what we wanted to talk about? This is what we want to get. This is what we want to talk about. K2d. Now, I've always said that I have a slight problem with Edge Kubernetes. Now, that's not to say that there's a problem with KubeEdge, because I think KubeEdge is actually a pretty cool platform. My problem is if you're actually really wanting to simplify Kubernetes, you can't just say, hey, we'll replace etcd because etcd is a little bit painful. Etcd is a little bit painful, but that's not the biggest problem with Kubernetes. You can learn to run etcd. The bigger problem with etcd or Kubernetes is that it's all painful from the API. Okay, you made a deployment. Can you access it? And the answer is no. Do you even know what machine it's running on? No. All of these things take time to learn, and you have to become really good at Kubernetes. Now, it's not saying that load balancers are hard to learn. It's not saying that replica sets are hard to learn, or stateful sets are hard to learn, or any of those things, or how to mount a volume into your Kubernetes cluster, or any of those types of things. None of them are particularly hard. It's just a lot of stuff. It's a lot of stuff, and if you want something really minimal, K3d still has all of that stuff. It doesn't remove any of that. It doesn't opinionate and make any of that type of stuff simpler. It just removes etcd. K2d. And this is something I have said for years. K2d is a stab at doing this. And now I don't know if it will do it well. I don't know if it's going to be awesome. I don't know, but it's a take on solving that problem, which I think it will be. It's an interesting take. So basically, they just use Docker. It's just Docker. And what K2d does is it takes your Kubernetes deployment manifest and it runs it on Docker. It just runs it on Docker with host networking. That's as much as I've seen so far. Now, we are also going to have to try this as well because I'm interested in understanding it more. And without actually trying it in a live stream, I don't know exactly what it's going to be. But it's pretty interesting to see this new take that they're taking for it. So basically, K2d is Kubernetes to Docker, which just translates the really simple Kubernetes deployment and runs it on something stupid simple. Docker is way easier to understand. It's way easier to understand the machine to the thing. There's none of this extra abstraction. So really awesome. Thanks to the community for bringing this up, and I'm looking forward to it. Now, we all know who makes Terraform. Nomad. I can name many products, but for some reason I'm blanking on their name. But they have competition. They have a lot of competition coming up, and the Linux Foundation formally takes in OpenTF and destroys its name to OpenTOFU. I can't believe they came up with his name. I know naming's hard. I feel like I make fun of a lot of names. But naming is hard, and I think it's proof with how much these people struggle with it. Now, this was either a brilliant marketing ploy because everybody was complaining about how terrible of a name it was, which is great publicity, or it's just a bad name that has the side effects of great publicity. So OpenTOFU is the Linux Foundation actually taking OpenTF. The OpenTF project that was started when HashiCorp, thank you, Russell, when HashiCorp switched their license to the BSL license, the project was forked into OpenTF. OpenTF has been adopted into the Linux Foundation now as OpenTOFU. I said from the start, whether OpenTF actually gains ground is how much industrial support is behind it, and it seems that this is actually getting a lot of support behind it, which could mean that you're looking at a bunch of people from Hardness, the people that make Gitness, the and Drone and whatnot. Spacelift, Scholar is another bigger known one. ExpressVPN. You're seeing enterprises starting to back OpenTOFU. So we're going to have to watch this more because I think that this could be a huge hit, a massive hit for Terraform not to be the de facto Terraform anymore. If OpenTOFU becomes the de facto Terraform, that will be a massive blow to HashiCorp. We'll see though. At this point, small fries compared to the big ones, but it's getting some backing. People like tofu. I'm not a fan of tofu. I'm not a fan of tofu. I'm not a fan of tofu for the name, nor am I a fan of eating it. I don't like either. Maybe I've never had it cooked well. That could be the case. Now, yet another open source tool for deployments has been released this week. Camel, not OCaml, Camel. Now, David Hansen comes out with his regular sass. He's a little sassy when he comes out. His opening ones are so clickbaity. I need to learn from him. I'll have to go to a really good Chinese restaurant. So they have released Camel, and I guess Camel came out from them deploying on their bare metal machines that they moved to. So Camel is a simple battle-tested deployment tool extracted from our cloud exit, which features zero downtime deploys, rolling restarts, asset binding, and just about everything else most people need to deploy and update their web applications. Now, I poked around a little bit. There's this pretty cool website that they released for it. You can go check out. It's written in Ruby. So I can't tell you that I'm ever going to contribute to it, because I'm not. I don't know Ruby nearly well enough. But it goes into a little bit of explanation of why they don't use these things, what they like about the approach that they took. And yeah, so it's an interesting thing to look at. Their vision is basically for, it almost to me looks like Elastic Beanstalk. If anybody used Elastic Beanstalk back in the day, it looks really simple. And if you have a simple use case, it seems like it might be really simple and maybe just works. Now, I think possibly if you got bigger, a much bigger service and whatnot, maybe it would be a little bit more difficult or need some features added to it to make it more compatible with things like Docker Swarm or Kubernetes or whatnot. When will David Hansen be releasing his own internet written in Ruby? Yeah. He maybe is a little too fond of Ruby, but I think it's cool. I think these are the types of projects. This is how I learn. These projects right here is how I learn. I take Kubernetes and how it does things and the pain points that it has. Then you take something like Camel and you look at what its pain points are, what it does well, what it does simply, and you learn from those things. It doesn't mean that I'm necessarily going to jump off and start using Camel for all of my deployments, but it's something you can still learn from. Nobody should just discount it because it's in Ruby or David Hansen. I guess people call him DHH just because DHH released it. No, I think that these have valuable learning things because they released it for a reason, because it made sense to them. So, yeah. All right, for all of you Rust loving, I combined the words again. Rust loving people out there, we need you to get up in arms over this RFC. This RFC fails to see. This RFC fails to understand Let me take a step back. This is less news and more of my opinion on this RFC. So there is a crates.io policy update RFC, which is going to update the policy. Now, they came out after some criticism and says the current policies are quite vague on a couple of topics. They're going to have new policies being a little bit more explicit. Now, they say this: reserving names is still allowed, but only to a certain degree, and if you have a good reason for it. I don't like this clarification. One, because they didn't actually change it in the policy. There's no new commit. It's still the same wording. They're just saying, trust me, bro. The other one is the crates.io team will try to contact owners before taking any actions. What does this even mean? Again, this doesn't update the RFC and the concerns the community voiced in the RFC. It merely says, trust me, bro. And I don't like that. I honestly don't. They have a real issue with name squatters. We have a real solution to name squatters. This is the problem. They have a real issue with name squatters, but they have a global namespace. Let me show you. The problem they need to do is that crates.io is globally namespace, which means if you want to go get Tokyo, you go to Tokyo and you get Tokyo, but it's just in a flat global namespace. Now, if you wanted to get Tokyo, just namespace it. You want it from the Tokyo project, the Tokyo owner. So your username should be your namespace. That's that simple. It solves most of the things that they're trying to do. Now, you could obviously get people that make a bunch of accounts, but that's different because that's not the name of your project. That's not the restricting what you can name your project, because now I can call myself, what happened if I want to make something for Tokyo, the city of Tokyo, and I want to call it Tokyo Explorer? I don't really want to conflict with this. I want this to be Merrick's Tokyo Explorer. I want it to be something like this. And this was a lot of the feedback that I had seen from this. They do have a problem with squatting. Let's take a look at this. Watch this. A minus, A minus minus, A bot, A underscore example. They have a problem with it, but I think that there's a better solution to going forward. I think having a global namespace makes it easier. Because now I can do Tokyo like this. If Tokyo doesn't have it, I can take it. And it doesn't have to have anything about Tokyo in it. And in fact, with the crates.io build system, and when I include it in my project, I can run malicious code on their project, them thinking it's Tokyo. But if Tokyo was like this, now I can't have Tokyo. I could have something close to Tokyo. But it could be Tokyo anything. It could be Tokyo's. It could be. I mean, like I don't think that the namespace makes it less secure. I think actually it makes it much harder for you to do it. Much harder. That's how most package managers work. Also, they are very vague. Basically, they say that they can do anything whenever they want. That's typo squatting. I agree. But it's hard to prove typo squatting. What if you wanted it to be Tokyo? Like, maybe that's what you wanted to name your project. Typo squatting is difficult, right? It's difficult to actually know that it's squatting. That's fine. You can disagree with it. I think it's a better approach. The other problem that they have here is basically, let's say you have a complete project. This is another problem that they have here. Let's say you have a complete project. You wrote it, it's good, and you don't want to touch it. Basically, they had something that after 6 months or a year, they would remove your project if you weren't continuously updating it, which causes problems again for people who that project is complete. You don't want it necessarily removed. I don't see them making an update to that, which would mean that they'll still remove it. Now, they say, trust me, we won't remove it, but that's just, again, trusting them that they won't remove it. But that's what this says. They'll remove it. But don't worry. They won't remove it without trying to contact you at least. All right. So, feel free to disagree with me. That's fine. But yeah, they basically, if you don't commit code to it for 6 months, it'll be no more. So if you have something that's there and useful, you can't hold on to it anymore. So no code can ever be complete. Yeah, 100%. This is their solution when I really think namespacing is, at least a good start. It's not fixing all the problems. I am not ever saying it's fixing all the problems, but it gives a lot of leverage for even projects to have the same name. How many copilots do we have? There are 100 copilots. It's actually maybe okay for projects to have the same name in a world flooded with project names. I'm not saying that I try to have projects with the same name, but it can be difficult. Yeah, I mean, you're right. Yeah, then you just get to automatically changing a readme modifier. But then what they have isn't solving anything. So it's still a bad RFC in the end because they're just going to get people that get around it. All right. And that's it for the open source. We only have a few more things left to go. I have some bad news for Round Rock, Texas. I actually agree with Google on something they said, which is pretty cool. And Cisco made a really large acquisition. So let's talk about it. Stale versus complete is a really hard topic, though. Let's say something is somewhat stale, but actually has functionality, and you're just not working on it at the moment. Should you get rid of it? Complete is a very relative term, you know? Nothing is perfect and nothing is complete in those terms. But let's take something that you're done working on and you're not going to work on it anymore. And you're not going to fix any issues that come up, but people still use it. Should that go away? It's stale. I mean, for the longest time, Gorilla Mux, a very popular one, was in that. There was no maintainer for it, but it just worked. Now, there were some issues that were raised for it, but they weren't getting fixed at the time. Would you just delete that one, even though people were still using it? I think this is the problem, is you're making things very vague and just up to a group of people that have made bad decisions in the past. You'd mark it as stale. Well, that's not in the RFC. The RFC says they'll delete it. So well, see, that's the problem, is they want to release the name. Marking it as stale is fine. I don't care. Their whole goal is to do this to release the name. That's the problem. That's why you namespace. Then you don't have to worry about releasing the name. Let Mark fill up Mark's namespace. It's fine. You know, I can have as many Merrick's repos as I like. Anyways, we don't need to divulge. I just think that they really need a namespace. Because trying to clean up the projects isn't the right approach. At least in my opinion. It's garbage collection for package management. Oh boy. All right. Google Fiber plans to expand to Round Rock. Good luck, Round Rock, for Google Fiber is going to tear up your roads and then leave the first time you have a winter. Now, this is in Texas, so maybe you're okay. But good luck. Good luck. I can tell you horror stories about what they'll do to your roads. Moving on to something really real, though. I love this statement from Google. This is about crypto. We've talked about crypto and my beliefs on crypto quite a bit, but what are the business problems that you want to get executed? When you're running a smart contract to execute some business logic to solve your business problem, you're using a token, but the token is not the thing. It's the business problem that's the thing. So this is what I've said for a very long time, and what I think really honestly the token exchanges ruined about crypto. I think there are very real aspects of crypto, of this type of blockchain technology that can actually solve business problems. The problem was that everyone was focused on the token, not the thing. This is actually why I made the video about how you could make a blockchain without a token in Git, because the whole idea there was to prove to people that the idea was more of there is a business logic that you're wanting to solve. In the case of Git, the thing is that you're trying to track how the code changed. In a shipping industry, it's how to track where your products are going. There are super awesome things that you can solve with blockchain, but the token is not the thing. I actually love this this statement. The token is not the thing. It's the business logic. It's the business problem that's the thing, and you're leveraging this to solve it. I wanted to shake this man's hand. I wanted to shake their hand. See you next, Null Dev. I'm so sorry I didn't get to the async part. We're so close. I'm so sorry. we got a little bit excited about the Rust packages. Blackberry jellyfish that do live for Jason Parson. Oh gosh. Oh gosh. All right. So Cisco makes the largest ever acquisition, buying cybersecurity Splunk for $28 billion. Now I have heard through the grapevines that this was because they wanted to stop paying for Datadog, and buying Splunk was cheaper. That was my favorite conspiracy theory out of this, that the 28 billion in cash for Splunk was cheaper than buying Datadog or paying for Datadog. It is a bunch of money to Splunk, a company who has almost consistently innovated throughout the years. So absolutely congratulations to them. Absolutely congratulations to them. Yeah, I didn't have a whole lot more to add on to that, except that it happened. And that there's a conspiracy theory that it was to stop paying Datadog. the conspiracy theory is plausible. That's what makes it so good. That's what makes it so good. Is you're like, no. Oh. There was a crypto exchange that was paying $63 million to Datadog. $63 million to Datadog. That is crazy. That is crazy. All right. Our last thing was this. Async Rust is a bad language. I haven't read this. But I'm interested in it. I'm interested in the take. Now, I think I'm going to have to pull this up really quick. Oh, I can't hear it. You know what? We're going to have to flip over here because we're going to have to pull up Excelidraw, because I think we're going to have to draw something here, I think. Because we're going to talk about threads, and I can't talk about... You have a pattern to reduce logging specifically for companies using Datadog. Would you mind coming on and talking about that pattern? Now, for all of you who don't know, I am taking next week off, and I'm looking to more focus these as well as get guest speakers on to talk about specific problems. So, Russell, I'm actually being serious. If you actually have that and would like to come on and talk about that, I would actually be thrilled to have a conversation about that pattern and to go over it. Okay. All right, async Rust is a bad language, but to get at whatever the hell I mean by that, we need to talk about why async Rust exists in the first place. Let's talk about modern concurrency. They're green, they're mean, and they ate my machine. Now, I have to warn you that a lot of people will talk about concurrency as not threaded, which means that it all happens serially and you just chopped up your process. I don't actually like that take because I think it's a bad wording, because concurrent usually means at the same time, which means parallel threads, because if you don't use parallel threads, then it's not concurrent. If you're only on a single thread, you just chopped up your execution to happen in fragments. And so I wouldn't consider that concurrent. But that's commonly what people refer to as concurrency versus parallelism. That's actually why I brought out the drawing, just in case people were confused by that. All right. Suppose we want our code to go fast. We have two big problems to solve. We want to use the whole computer. Code runs on CPUs, and in 2023, even my phone has 8 cores. If I want to use more than 12% of my machine, I need to use several cores. We want to keep working while we wait for slow things to complete instead of just twiddling our thumbs. Sending a message over the internet or even opening a file takes eternities in computer time. We could literally do millions of other things meanwhile. So basically, we can do stuff while we wait for other stuff. And so we turn to our friends parallelism and concurrency. Again, I don't like separating these things out because I think it's actually confusing because English would dictate that this means multiple things at the same time, indicative of parallelism. It's our favorite hobby of CS nerds to quibble over distinctions between the two. So to oversimplify, parallelism about running code in parallel on several CPUs. Concurrency is breaking the problem into separate independent parts. This is why I don't like concurrency. He's absolutely right. That is what most people think of it as. These are not the same things. Single-core machines can have been running code concurrently for half of a century now. See, they're not running it concurrently. That's the whole problem with the word. But yes, it's just breaking it up. So it's non-sequential. So I would contend that this is non-sequential programming, which is fine and good, and I think actually makes more sense to call it non-sequential. But they're related. So much online. Well, Ashkemening ignores how we often break programs into concurrent pieces so that those pieces can run in parallel. So basically, you break the pieces up so that they can run in parallel and interact really in ways to keep our cores turning. So you can use all of the CPU. How do I concurrency? One of the simplest ways to build a concurrent system is to split code into multiple processes. After all, the operating system is lean, mean, concurrency machine. Conspiring with your hardware to make each process think of its whole box to itself, and the OS scheduler gives us parallelism for free. Running time slices of any process that's ready on available CPU cores. Once upon a time, this was the way, and we still employ it today, whether we pipe shell commands together. But this approach has limitations. Inter-process communication is not cheap, since most implementations just copy data to OS memory and back. So basically, talking between two threads isn't I say threads, but I mean like CPU processes or OS processes isn't cheap. Mutate-based concurrencies considered harmful, or Jorge was right. Some people, when confronted with a problem, think, I'll use threads, and then they have two problems. Obviously, this is multi-threaded. We can avoid these overheads using threads, processes that share the same memory. Common wisdom teaches us to connect them with mysterious beasts like mutexes, condition variables, and semaphores. This is a dangerous game. Simple mistakes will plague you with race conditions, deadlocks, and other terrible diseases that fill your code with bugs. But only on Tuesdays when it's raining and the temperature is a multiple of 3. And help you if you want to learn how this stuff actually works on modern hardware. There is already a way. In this paper, Communicating Sequential Processes, Tony Jorge suggested connecting threads with queues or channels, which they can be used to send messages. This has a lot to do with small talk as well as basic object-oriented message passing type of paradigm. The actor paradigm would be a good one. Or threads enjoy process-like isolations from the rest of the program since they don't share memory. Each thread has a very obvious set of inputs, the channels it receives from, and outputs, the channels it sends to. This is easy to reason about and easy to debug. Yeah. Instrument the channels for powerful visibility into your system. Channels are the synchronization. So channels are how you're synchronizing between the threads. Absolutely right. And you can effectively have queues. A lot of those channels actually have queues in them. So like if one thread is pumping more messages than the other one can handle, they'll use it. If a channel is empty, the receiver will wait until it's not. If a channel is full, the sender waits. Threads never sleep while they have work to do, and graceful pause if they outpace the rest of the system. Tony Hore is the Mr. Null. I'm not the Mr. Null. I'm like the Junior Null. I'm Null Junior. I'm his son. And I have no regrets with what my dad did. He might have regrets. I don't have any regrets. He's my spirit father. You're the spirit animal, Russell. He's the spirit father. After decades of mutex madness, many modern languages heed Hore's advice and provide channels in their standard library. In Rust, we call them this. There's also Tokyo has their own set of channels, which are async and awaitable. Most software can stop here, but building concurrent systems with threads and channels combine them with tools to parallelize CPU-intensive loops like Rust Rayon or Haskell's PAR. Rayon is much different than, I don't think Rust's Rayon. Tokyo would be a better example here. Hey, it's what chat said, Russell. It wasn't me that called you the spirit animal of the Null channel. They called you the spirit animal. Ludicrous speed. That's what we want. Blazingly fast. He missed the term. In Rust, it's blazingly fast. Some problems demand a lot of concurrency. The canonical example described by Dan Kaggle as the C10K problem back in 1990 as a web server connects to 10,000 of concurrent users. Now, I want to point out here, he's mixing two things here. This is a Tokyo problem. This Rayon doesn't do this well because they are looking at process intensive versus IO intensive. So a lot of times a web server is disk IO intensive, and you want to have tens of thousands of concurrent users, but you don't want to have a thread for each one of them. Whereas Rayon is going to croak with this. Most likely. It's just not designed for it. You're insulted by everyone. I think you insulted everyone first, but we won't split hairs. At this scale, threads won't cut it. While they're pretty cheap, fire up a thread per connection and your computer will grind to a halt. Absolutely. That's, yeah. You're going to have PID thrashing, thread thrashing, because basically your CPU has to switch contexts, and switching contexts actually takes time. And what happens is basically your CPU just spends all of its time switching contexts. All right. To solve this, some languages provide a concurrency model. Tasks are created and managed in user space without the operating system's help. A runtime schedules these tasks into a pool of OS threads, usually sized so that each CPU core gets a thread to maximize parallelism. So basically, this is like the Tokyo engine, the runtime engine that's going to run these things. This scheme goes by many names: green threads, lightweight processes. This is the same thing as Go's concurrency. Yeah, that's what these are. Rust comes with this problem with an async await model. Seen previously in places like C# and Node.js. Here, functions marked with async don't block, but immediately return a future or a promise that can be awaited to produce the result. Yep. Oh, I like that. That's pretty good. Pain.await. On one hand, futures in Rust are exceedingly small and fast. Some might even say blazingly fast, thanks to their cooperatively scheduled stackless design. But unlike other languages with user space concurrency, Rust tries to offer this abstraction while also promising the programmer total low-level control. There's a fundamental tension between the two. All right, I got in an argument Thursday with somebody, I think, about this on stream. And I think this is a positive and a negative because it hurts new people into that was my thing, is that it's hard for new people to get into it. There's a fundamental tension between the two, and the poor async Rust programmers is particularly caught in the middle, torn between the language's design goals and the massively concurrent world that they're trying to build. Rust attempts to statically verify the lifetimes of every object and reference in your program, all at compile time. Future promises the opposite, that we can break code and the data it references into thousands of little pieces, runnable at any time on any thread based on conditions we can only know. This is where, if he's going to start talking about pinning memory, he went way over the deep end, and you don't need to do that to start using it. A future that reads data from a client should only run when the client's socket has data to read, and no lifetime annotations will tell us when that might be. Send help. Assuming the compiler that everything will be okay runs into the same challenges you see when working with raw threads. Data must either be marked send and moved, or pass through references with static lifetime. Both are easier said than done. Moving, at least without cloning, is often a non-starter, since it's common in async code to spawn many tasks that share common state. And references are painful too. There's no thread scope equivalent to help us bound future's lifetime to anything short of forever. So here he's passing references, and here he's cloning. Okay. That's fine. And he's just saying this has a static lifetime. That's fine. Okay. And unlike launching raw threads, where you might have to deal with those asynchronous annoyances in a handful of functions, this happens constantly due to an async viral nature. Since any function that calls an async function itself must be async, you need to solve this problem everywhere all the time. Just arc my stuff up. A seasoned Rust developer will respond by saying that Rust gives us more simple tools for dynamic lifetime, spanning multiple threads. We call them automatic reference counts, or ARC, something like what Swift uses. While it's true that they solve the immutable problem, borrow checkers, and our code compiles, they're far from a silver bullet. Used persuasively, ARC gives the world's worst garbage collector. Like a garbage collector, the lifetime of objects and resources they represent, memory, file, sockets, is unknowable. But you take this loss without any wins when you don't get garbage collection with it, is what he's saying. And don't buy the GC as slow FUD. The claim is misleading of latency versus throughput at best, and a bizarre. Okay, I disagree with this. Don't buy into the GC as slow FUD. So GC isn't slow. GC isn't slow. It is the unpredictability of GC. That is more of the thing. So the problem is you can't always predict when GC will run. You can't predict what impact it will have. And when you have things with a bunch of objects that get GC'd, you can actually thrash the GC. The actual ask of GC is not slow. The thing with Rust is it's a constant. Things are getting cleaned up as they're being used and gotten rid of. It's a constant set of things. It's always happening. So you never have the unpredictability that you'll have with a GC system. Now, I would say that GC is slightly slower, but I'm not going to say like a lightweight GC like Golang is massively slow. It's just unpredictable. It's not slow until it happens on your critical path. That's right. Like, that's the problem, is it can be unpredictable, and you don't know when it's going to stop a critical path or something like that. A modern moving garbage collector lets you more allocation throughput, less fragmentation. It means you don't have to play Mickey Mouse games with weak pointers to avoid cycle leaks. You can even trick system programmers into leveraging GC in one of the world's most important software projects by calling it deferred destruction. Okay, let's move on. So far, other than this, it's been pretty on point. Other random nonsense. Because Rust coroutines are stackless, the compiler turns each one into a state machine that advances to the next await. But this makes any recursive async function a recursive defined type. A user just trying to call a function from itself is met with an instructable errors until they manually box it or use a crate that does the same. Fair, but you don't really have to deal with this for the most part. There's an important distinction between a future, which does nothing until awaited, and a task, which spawns work in a runtime's thread pool, returning a future that marks its completion. Yeah, but you really don't need to know about this either. There's nothing that... This is talking about implementation details. I don't think implementation details on the language is fair. Like... This is implementation details. This is implementation details. He didn't bring up C-Sharp's implementation because I think the thing is C-Sharp hides it better, probably. That would be my guess. And so they just don't know how it's implemented in interiorly. I can tell you I don't myself. There's nothing keeping you from calling blocking code inside a future, and there's nothing keeping... So again, if it's blocking code, it should be either awaited or you're talking about something like Rayon that's going to be using it. This is just not knowing what type of thread you want. C# wasn't going to handle this any better. Does C# use state machines? I imagine it does. I don't know how else you would deal with it, but I imagine it does. Also, all code is blocking code. So I don't get this statement. There's nothing keeping that call from blocking the runtime thread it's on. Nothing has this. So every green thread, you can run without yielding. You can run without yielding. The only one that does this is Go. And because Go will force it to yield. But this actually causes problems because did you know that Go will force a thing to yield? Their Go routines. And did you know because of that in the C runtime that's mostly Go, it actually calls C because it has to promise the kernel to call back on the same thread, and you can't do that in Go. So Go's whole thing where it will do that actually causes problem with real programming. Oh, okay. You can still call blocking APIs with async functions. That is true. Mixed together, this all gives async Rust a much different flavor than normal Rust, one of many more gotchas. It is harder to understand and teach, and it pushes users to either develop a deep understanding of how abstractions actually work, writing complicated code to handle them, or sprinkle arc, pin, and I will say, if you are sprinkling pin into something, you probably need to take a step back. Unless if you're writing a custom future, and if you're pinning something, you've probably made a mistake somewhere else. Not always, but it's a good smell. It's a good smell. Not a good smell. It's a bad smell. It's a smell. Let me throw that there. All right, people might call these overblown, but I've seen a whole lot of teams of experienced developers trying to use Rust for some new project, mirrored in the minutia to whatever challenge teaching Rust has. Async adds a whole new set. Agreed. It's a whole new set. The degree to which these problems aren't a thing in other languages can't be overstated. Either in Haskell or Go, async code is just normal code. See, I think the minutia in Go bites you in the butt when you don't understand it well. He obviously hasn't. He has never tried to call from the same thread because you can't. You can't do it in Go. It's impossible. Which means if you need to do that, like when you're making a namespace, you're screwed. You have to run C code to do it from your Go. You might say that's not a fair comparison. After all, those languages hide the difference between blocking and non-blocking code behind fat runtimes, and lifetimes are hand-waved with garbage collection, but that's exactly the point. There are pure wins when we're doing this part of programming. Maybe Rust isn't a good tool for massively concurrent user space software. I don't agree with this. Rust is great for massively concurrent user space software. if you know how to use it. I think this is like agreeing to the same thing, but coming to a different conclusion. What he's saying is that Rust is harder to understand and learn. Everyone has ever known this. No one ever disagrees that Rust doesn't have a steeper learning curve at the beginning. That is a fair point. That doesn't mean that you can't do user space software, massively concurrent user space software. It just means you have to know Rust well enough to do it. I've been meaning to do a deep dive on Rust threads. So we're going to do some more on streams. We're going to do some more on streams for Rust threads because I think there needs to be a whole mini series where we do highly concurrent projects, highly concurrent threaded projects. And yes, Russell, that would be my point. Rust is a higher bar to be able to do well, a higher bar of understanding to be able to do well. And Rust threading, you can absolutely shoot yourself in the foot with. Honestly, Rust and even its lifetimes are fairly easy and simple as long as you don't thread. Threading does bring in a lot of issues that make it much more difficult. I even consider myself a decent novice at threading in Rust. Yeah. So there's a lot that goes into threading and being blazingly fast. Now, I think Tokyo handles a lot of this for you. I think the main things that they were talking about maybe aren't that big of a deal as long as you leverage Tokyo. Now, the people that write Tokyo have to know threading in Rust amazingly well. But that's a different topic. Now, I have another article, but we'll save it for another date. It's called Zero Configuration Service Mesh with On-Design Cluster Discovery. Now, for a lot of you, I know that we don't want service mesh, but that's okay. Not everybody needs to learn it to understand how Netflix solved a problem and to learn from it. So this isn't me going to push that we use service meshes from now on. This is me saying, hey, look, they did something. But we're not going to cover that today. Maybe in 2 weeks. Maybe in 2 weeks. So I haven't decided whether I will take a break from this normal series when we boot up the little bit newer version of the news. I'd be interested in your guys' feedback on your thoughts on that, who you would like me to see, and do you know somebody that would be willing to join? I don't know if I know enough people to consistently get people on here, but I'm going to be trying my best to find some people. Maybe there's some people that we could have more often than it doesn't have to be a new person every single time. So yeah, we'll get that going, but I don't know. I might take a break between those, getting those started or not. But next week is a break for sure. I'm going to be out. Catch me on Tuesdays and Thursday night if you'd like. But other than that, next week I'm off. And yeah, that's it for the news. Did you guys see anything else that I missed? Ooh, do it once a month. That's a good idea. Do it kind of like podcast style once a month. I like that. You spot something called electric squirrel. I have never seen electric squirrel. Electric squirrel, the missing sync layer for modern apps. The reactive sync layer for super fast apps. The conflict-free sync layer for collaborative apps. What is this electric squirrel? And does it have a Rust bindings? Does it work in Rust? That's the number one question we have to ask. Yeah, the CRDTs are interesting. I've never done a ton with CRDTs. I've never written an app that's like that. I'm interested in this. This looks interesting. This is so many words. Local first sync layer for web and mobile apps. Build reactive, real-time, local first apps directly on Postgres. This is cool. Thanks for bringing it up. I want to bring these projects up in the open source portion. Some of it is just knowing that a project exists, and that can be difficult to know. So I need to do better about that. So definitely bring these up at the beginning or at the end if you like, or a little time beforehand. I think it's really great to have a spot to share some of those just to learn about them, just to learn that they even exist. That's a lot of words, though. That's interesting. All right. Anyways, I'm going to get going. Thank you, everybody, for watching. And I will see you guys not next week, the week after.